Welcome to Spectral. My name is Timothy Lattis, and this is the Neo-Kino Graphics channel. There are some interesting aspects of monochrome rendering. I have at least one project which is designed to be monochrome, and there are some interesting possibilities on the display side by dropping. Perhaps one of the best examples of leveraging monochrome for a game would be Limbo. Perhaps the desire for monochrome rendering comes from a love for black and white photography. Black and white enables a focus on lighting and texture, while breaking the human's easy color-based object segmentation ability. In other words, you can get away with a lot in black and white that you wouldn't be able to do in color, especially when it comes to tonal changes of the image. So let's dive into the displays and see if there's anything we can do to benefit from monochrome rendering. With color, chroma decimation works against you, but with monochrome, chroma decimation can actually be leveraged for higher peak frame rate. Moving from 444 to 420 almost cuts the bandwidth in half, which will enable a higher peak FPS. DisplayPort actually supports Luma-only rendering, but I'm not sure how to get that mode. DisplayPort 1.0 supports 422, and DisplayPort 1.3 supports 420. HDMI 1.0, 422 is only optional, so it might not be available. But by HDMI 2, there is support for 420. So in practice, let's say you had a Steam machine and you're limited to a DisplayPort 1.4. Now we can compare at different resolutions and different bits per pixel what we would get with color versus what we get with monochrome with the 420 decimation. So 1440p at 8 bits per channel gives you 251 FPS at 444. With chroma decimation, you can get up to 430 FPS, which means you'd be able to hit a 360 Hz display. At 1440p at 10 bits per channel, now you have 205 FPS with color at 444. However, you'd be able to get to 351 FPS at 420, which means you can now target a 240 Hz HDR display. However, at 4K at 8 bits per channel, you'd be limited to about 120 FPS with no chroma decimation. But with chroma decimation, you can only get up to, say, 205 FPS. So you'd still need DSC here if you want to target the higher 240 Hz. Also at 4K with 10 bits per channel, you'd only get 97 FPS at 444, and you could hit 166 FPS with chroma decimation, which means that now 4K at 10 bits per channel is good for 120, 144, and 1 Hz for monochrome in HDR. Another question is, would monochrome provide any benefit on the WOLEDs? Nice thing about monochrome is you don't have to worry about the gamma reduction problem anymore. In theory, you could leverage HDR modes with shader BFI. However, it would only probably work at high FPS. So this particular monitor I'm looking at from TFT Central has a 381 nit stable. If we were to do a 60 Hz render and bring that up to 120 Hz using shader BFI, we would be somewhere above a 50% APL, and you'd only get roughly 466 nits. So it's probably not worth it at 120 Hz. And similarly, once we go up to 240 Hz and an 80 Hz render, now we're down to a 33%, somewhere above a 33% APL, and so you're looking at best 500 nits. It's still not double. However, when we start reaching into the 480 or the 540 Hz, and you're running, say, a 60 Hz render at 540 Hz, you'd be somewhere above a 12% APL, which means your peak might be around 825 nits on this particular monitor. And so if we're somewhere in that vicinity, we're probably going to be around 2 stops. So the interesting aspect of a rolling frame CRT simulation is you only see part of the frame in a given frame. So you're not bringing the whole entire screen all the way up to full brightness as you would with a non-rolling one, which is why this technique might actually work. So that's it for this talk. I want to leave you guys with some alternative rendering inspiration. For instance, scanning electron microscopy produces a very interesting image. Also, X-ray photography produces a very interesting image.